Alright, let's take a look now at the Michael reaction. Now the Michael reaction is a 1,4 addition to an alpha-beta unsaturated dicarbonyl system, very similar to one we've looked at earlier. And what we're looking at here is the attack of a nucleophile, and it's going to be at this position, and we end up, if you look at the pattern, we get the nucleophile attached at this carbon and we've lost the double bond. What I'd like to do is go through and show you a couple of examples. And what I'm going to do is show you an example of a nucleophile with a negative charge on it and a nucleophile that's an amine as well. There's two different ways that this reaction can be presented to you. You can have the nucleophile above the arrow already formed, or you can have the nucleophile unformed along with the Michael substrate, as well as a base above the arrow. Now the base, what's going to happen is it's going to remove the proton from the nucleophile and form the Nu- in the first step. And then the Nu- will go ahead and attack this reagent in the same way as it does up here. Alright, I'm going to show you an example of that one as well. Alright, so this is an example of the first one that has a nucleophile already formed. Because of the nature of the anion here, it's a soft anion, so it's going to attack this, it's a soft negative charge, it's going to attack this soft positive charge. If you want to know more about that, go back to my earlier mini lecture that talks about attacks on the 1,4 positions of alpha-beta unsaturated carbonyl compounds. Alright, so that's what it does, it'll attack there. And that's where it attaches. Then we can add the H plus in the next step. And we get our familiar enol compound. And as we know, enols are in equilibrium with their carbonyl counterparts. And that's how we end up with our product. But the overall effect you can see is that we've added the nucleophile to the end of this double bond and lost the double bond. So you can see it's a fairly simple pattern. Alright, let's take a look at the amine reaction. So amines are soft nucleophiles as well. So it'll attack the 4 position of the alpha-beta unsaturated carbonyl system. Oops. That O will have a negative charge. And the amine will have a positive charge. I have a double bond here as well. And then the negative charge can pick up the proton of the amine. So we've got a proton transfer step going on there. And it's a little different to the previous one because we're dealing with a neutral compound and not one that was initially negatively charged. Alright, so now we can form the carbonyl compound of the enol, and you see that we've pretty much got the same pattern going on here as we had for the previous one. Alright, so that would be how the amine would add to the 1,4 system. Alright, let's take a look at another example. This is one where the anion is not preformed, where we have to form it using a base, and the base is given to us as part of the reactants here. This is N-butyllithium. It's a very strong base. We've used it before. We used it in the Wittig reaction. Right, so what we want to do first is remove the proton from what will be the nucleophile, and that would be this compound here. And N-butyllithium looks like that. It's got a negative charge on the end, very unstable negative charge. It would love to rip a proton from something. So we'll rip it from that, and that'll give us our nucleophile, which we'll classify as a soft nucleophile as well. And butane will also be formed as a side product there, and that will just basically float away. So now we've got our double bond compound, and the nucleophile can now come in and attack that. And the mechanism is going to be pretty similar to what we just dealt with. Alright, so now we've got our nucleophile joined on, we can add the H plus in the second step, and that will give us our enol. And then we can move that H to the other side, makes it a little bit easier. And then we can reform the ketone. And then we'll have our product. That's it.